Hello, today I am going to discuss about finite difference approximation method for solving first order differential equation. So, our topic is finite difference approximation. So, we will talk about three approximation methods: first order finite difference approximation, first order backward difference approximation, and a second order centered different approximation. So first order finite difference approximation, I am calling it as FDA. So according to this, the formula is xn dash equal to xn plus 1 minus xn divided by delta t. So let me show. So the differential equation we want to solve is dy dx. Let's write this differential equation: dx dt equal to fxt. So this is the differential equation we want to solve. So this is a first order differential equation. So first order finite difference approximation formula is this. So this is first order. So the order is delta t. So I will discuss why this is called first order. Okay. The second approximation method I am concerned about a first order backward difference approximation. First order backward difference approximation. So the formula for this is x dash n plus 1 dash is the derivative, xn plus 1 minus xn by delta t. This is also first order. So I will discuss why this is first order. And third one is second order centered difference approximation. So this is second order centered difference approximation. So here the formula is x dash n plus half equal to x n plus 1 minus xn divided by delta t, and this is order is delta t squared. So this is second order. So the reason I am making this video is that I want to explain why this is first order, this is first order, and this is second order. So I will go through these three processes, these three methods, approximation methods to solve first order differential equations one by one. So first of all, first order finite difference approximation, that is this one, first order finite difference approximation. Okay, so let's do a Taylor expansion xn plus 1. So xn plus 1 is basically xn plus 1 is equivalent to x tn plus delta t. So I am doing Taylor expansion. So this is xn plus xn dash delta t plus half x double dash n delta t square plus dot dot dot. Okay, so from there we will consider this till this delta t terms. So using this we can write xn dash equal to xn plus 1 minus xn by delta t. So this is the formula I wrote previously. So what I did is that I neglected from this second order term. So I only considered first order term. So that's why the since I only considered first order of delta t, that's why this is called first order approximation. And why this is forward? Because so from there we can write xn plus 1 equal to xn plus delta t xn dash, and xn dash is basically dx dt, which is f xn comma tn. So this n plus 1, what we want to calculate, xn plus 1 only depends on the quantities of at nth point. So that is why we are going step by step. This is n, this is n plus 1, then n plus 2. So always going to forward direction. So this is called first order finite difference approximation. And since we are considering till delta t order, this is called, that's why I wrote this is order delta t. Okay. Now second one is the backward difference. That is also first order. I will explain why. So now I will do a backward Taylor expansion. So this is, I will expand xn around xn plus 1. So what will be the Taylor expansion? This is xn plus 1 minus xn plus 1 dash delta t plus double derivative at n plus 1 tn plus at t n plus 1 delta t square by 2. Now again take till order delta t. So you can write again xn plus 1 dash equal to xn plus 1 minus xn by delta t. So again you can see that we took only delta t order. So again this is first order, so the order is delta t. And you can write xn plus 1 as xn plus delta t xn plus 1 dash. So this is basically xn plus delta t. This is f xn plus 1 tn plus 1, xn plus 1 t n plus 1. So you can see why this is called backward difference, because we want to know xn plus 1, but for that we have to know the derivative at that point, xn plus 1 tn plus 1. So that is the reason it is called backward difference. And obviously the order is delta t. So these two, as I said, the order delta t, and I proved it. And the third method is second order centered difference approximation, and here the order is delta t square. So I will show that. So to show the centered difference approximation, I will expand xn plus 1 around xn plus half point. So actually I am writing x tn plus 1 expanding around x tn plus half. So if we expand this, what we will get is that this will give x n plus half plus first derivative at n plus half delta t by 2 actually, because this n plus 1 minus this will give half. So this is delta t by 2 plus half x double dash n plus half and delta t by 2 square, right? So this is delta t square this will become 8, and then minus, and we will also do a Taylor expansion of xn around n plus half. So this is half minus xn plus half delta t by 2, and plus, sorry, this is plus, yeah, and then again plus 1 by 8 x double dash n plus half delta t squared minus dot dot dot. So now now what I will do is that I will take this will give, what we will get is that, yeah, so this term is got cancelled, and here I am getting x dash n plus half delta t, and again this got cancelled, and after that we will get delta tq order term, right? Yeah, delta tq order term. So if we divide it, xn plus 1 minus xn by delta t equal to n plus half plus order of delta t square. So you can see that half dash equal to xn plus 1 minus xn by delta t, and the neglecting the term till delta t square. So that's why it is called second order centered difference approximation. So briefly I will tell once more to repeat. For the first order finite difference approximation, we are expanding this, and if we, another way, if we divide by delta t, so this term we are neglecting, divided by delta t becomes order of delta t, right? Order of delta t, and that is why this is first order. And here again we are neglecting this term, and if you divide it by delta t, we are neglecting basically order delta t. So this is first order. But in this case what we got is that this is second order. So this is first order finite difference approximation, this is first order backward difference approximation, and this is second order centered difference approximation. Thank you.